All right, in this video, I'm going to go over solving inequalities. Now, with inequalities, your answer is not going to be just one number. Your answer is going to be a set of numbers because instead of an equal sign, we have an inequality symbol. Now, there are some important rules about this that we're going to go over. But for the most part, there's just one exception to the rule, but for the most part, it's exactly like solving an equation. So it's really not that bad. So let's start with x plus 7 is greater than 9. We want to just get x by itself, right? So we treat it like we're solving an equation. Subtract 7 from both sides, right? 7 minus 7 is 0, so that cancels out. 9 minus 7 is 2, right? So x is greater than 2. That's your answer. It's easy. But just to be on the safe side, let's practice writing things in interval notation, because sometimes you'll get a problem like this and they'll ask you to express your answer in interval notation. So just as a refresher, what is interval notation? Well, we got the number 2 here, right? And we're not including it. And x is greater than 2, so we want the parentheses on the left, and we want to go to positive infinity because x is greater than, right? So there is your answer. Everything, all the numbers greater than 2. 2.000000001, and all the numbers greater than that. But not including 2. Now, let's solve this one. Okay, we got x on both sides here, and we got an or equal to sign. But that doesn't change anything, right? Doesn't change much. We want to get x by itself, right? Do we want on the left or the right? I mean, that's your choice. Subtract 13 from both sides. That goes away. Negative 7x greater than or equal to 10x. Negative 4 minus another 13 is negative 17. Okay. Now we want the x's on this side, so we're going to subtract 10x from that side. Subtract 10x. Well, negative 7 minus 10x, negative 17x. That's a negative 17 going on here. Okay. Divide both sides by negative 17. This is the exception to the rule. This is where inequalities differ from solving equations, right? When we divide or multiply both sides by a negative number, it flips the sign. That's the only rule you got to remember. But negative 17 divided by negative 17 is 1. So x, we're dividing by a negative number. So now it's less than or equal to. That is the big thing you have to remember. Negative 17 divided by negative 17 is 1. And we're less than, right? So we're going to the left, and we're including negative infinity. And there's our answer. And you want to put this to the test, see if it actually works. What if we plugged in 0? Because that's less than 1, right? So 0 should work. 0, 13 minus 0 is 13. Greater than or equal to 10 times 0 is 0. Negative 4. Yeah, 13 is greater than or equal to negative 4. What if we put in a 2, though? 2. So 13 minus 7 times 2 is 14, right? greater than or equal to 10 times 2 is 20 minus 4. Is that 16? Minus 4. Negative 1 is not greater than or equal to 16. And 2 is not in our range. So this confirms that this answer is correct. Interesting. If we hadn't swapped, inverted the sign here, we would have gotten the wrong answer. So you got to remember to do that. When dividing, multiplying, or dividing by a negative. That is the major rule you got to remember. All right. 3x less than 6. Let's try this one. Divide both sides by 3. It's not a negative. So things turn out okay. Don't have to switch the sign. And x is less than 2, right? So there's our answer. Check. We put in 1. 3 is less than 6. Yeah. 3 times 1 is less than 6. Yep. All right. Put in a 3. 3 times 3 less than 6. No. So that's correct. Did not have to swap the sign there. Do have to swap the sign here, even though we're doing a division in both. But this division was by a negative number. Why, though? Why do we have to swap it? Because it changes the signs on both sides. It changes the sign. See, this was a negative and now it's a positive. This was a negative and now it's positive. You know, and sometimes this will be a positive and dividing by a negative will make it a negative, you know, but because it changes the sign of both sides, we change the sign in the middle. Interesting way to look at it. All right, one more example with fractions, and then we're done. So what do we do here? Well, we want to get the x's together, right? So we need to subtract 8/3 x from both sides. So negative 5/6 x minus 8/3 x is less than or equal to 3/4. Okay. We need common denominator to subtract them, right? So what do we multiply by 3 to get 6? Multiply by 2, so we multiply 8 by 2. We get negative 16/6x. It's the same number, just expressed in different denominations. Negative 5 minus 16. Now we can focus on the numerators. Negative 21/6x less than or equal to 3/4. Okay. This reduces, doesn't it? Always think about reducing fractions if you can. It just makes things easier. 6 divided by 3 and you get 2. Whoa, that's bad. 2 divided by 3 and you get 7. So 7/2. Multiply both sides by negative 2/7. The reciprocal, right? To get rid of it, because 7 divided by 7 and negative 2 divided by negative 2 cancels it all out, right? We're just left with x. Oh, I almost made a mistake there. We're multiplying and dividing by a negative, right? So that changes the sign. Gotta remember the rules, Joe. All right, so we're multiplying this fraction out. We can cross cancel a little bit, can't we? That makes things a little nicer. Negative 3 over 2 times 7, which is 14. Okay. And we want to express that in interval notation, right? We're including the negative 3/14, and we're larger than that, so we're going to positive infinity. That is a terrible bracket. There we go.